Welcome to lesson 51, and in this lesson we're going to evaluate algebraic expressions that have decimals and fractions. Here are the things you're going to see me do in our model that you will practice in today's lesson. One, that you can substitute for multiple unknowns, so lots of different variables in the expression, and that we can recognize the coefficients represent multiplication. So double check that you know that. Teachers can tell if you're putting a parentheses around between your coefficient and your variable when you substitute, so we know you're multiplying and not just putting the two numbers together. And finally, that you can attend to precision. In other words, that you're being really careful and thoughtful and really organized with your work. So let's jump into the first problem. Evaluate the following: 3c plus d plus 2f plus s using the variables on the menu. So pretty much we want to know what is the value of the expression using all those prices on the menu. Here's our facts. They're all just prices for the menu. So I know C meant cheeseburgers, D meant the double-double, F meant fries, and S meant shakes. And I have all the prices there directly from the menu. And here's my plan. We're going to substitute the prices for each variable in the expression using those prices on the menu. And we're going to use our order of operations to simplify the expression. And again, attending to that precision, I'm going to make sure that my work is clear and organized so that I can follow my steps and other people can as well when they give me feedback. Hit pause so you can jot this down into your notes. Okay, let's start with our substitutions using everything in the chart. We can see them here, all different items. And remember, we're using parentheses to separate any time we see a coefficient and a variable. We see it two times so that we know it's multiplication. We don't make that Carolina mistake. Okay, so starting off with 3 times cheeseburgers. Giving myself a lot of room here. 3 times $2.75. Plus, D is for the double cheeseburger. $3.95 plus 2 times $1.85 plus our shake $2.50. So there we have it. We have all our numbers. Now we're going to slim this down when using our order of operations. Again, we can't do any adding until we figure out everything else. So all our numbers are actually in parentheses. So I know normally our first step is do what's inside the parentheses. There's no operation in there. So we're going to move to the next step. There are no exponents. There are no parentheses. No exponents. So now we're going to multiply or divide from left to right. So we're going to start with our first one. 3 times $2.75. 3 times $2.75. And that's going to give us $8.25 plus $3.95 plus. Now we're going to do 2 times $1.85, and we have $3.70 plus $2.50. So we've taken care of all our multiplying and dividing from left to right. So we're ready to add or subtract. So we're going to do our first two numbers over here. So $8.25 plus $3.95. And we have $12.20. All right, I'm still going to go from left to right. So I'm going to add these two together. And I actually don't need a calculator for this one. This would be 12 plus 3 is 15, and 20 plus 70 is 90 cents. And I'm not using a calculator. I didn't have to do any regrouping. And now I have our final step, $15.90 plus our 50 cents. Now, there are actually some things I'm doing in my brain. I do want to make it kind of sense so you can kind of see what I'm doing. In my mind, I'm taking 10 cents from here, 10 cents. And I'm putting it over here to make this $16. So that's what's actually happening in my mind. If you were in there, you would actually see I would have 16 plus $2.40, because that is mental math that I can do. There are so many different ways people can creatively add and subtract numbers. I just like making things whole dollars because it's way easier for me to add up. But if you weren't sure, if you just wanted to add those two together, and you could, you would still get $18.40. $15.90 plus $2.50. There we go. $18.40. This is why we always check our work. We want to just double check, and I'd rather check twice than have an error. But that is the final cost for all the meals. The final answer after substituting and simplifying is, I'm trying to write this as neatly as I can, $18.40. So hit pause and jot this down. Definitely biggest takeaways, make sure when you're substituting you are very careful with any coefficients and using your parentheses, and then use your order of operations to do the problem piece by piece. It's meant to slow down your thinking. Yes, it takes longer, but I'd rather take the time in the beginning and make a mistake than to make errors throughout. We have two more to go, but these are pretty simple. This first one, we have 12 5/10 y, and we want this when y is equal to 7/10. So it's the same operation. We're still substituting and then evaluating. It's just our numbers now are a little bit more complicated because they have decimals, but the math stays the same. So I'm still going to substitute, and I'm going to have our y in there. So there we have it. And now I'm just going to evaluate. What is 12 5/10 times 7/10? I'm not going to use a calculator for this one. More likely, if you get a question like this, it will be on the first day of the 6th grade New York test, which means you're not going to get a calculator. So instead, I'm just going to carefully do my work. Remember, we're going to ignore the decimal at first. We're just going to multiply. 7 times 5 is 35. 7 times 2 is 14. 14 plus 3 is 17. 7 times 1 is 7 plus 1 is 8. And now I have two decimals, so I'm going to move this 2 spaces to get 8 and 75 hundredths. There you have it. It's still a one-step substitution, but notice that parentheses really matters. About it, you get a very funky, weird number. So let's jot this one down into our notes. Alright, let's read this last problem together. The area A of a square with a side length S can be determined using the formula area equals side squared. What is the area in square centimeters of a square that has a side length of 1 7/10 centimeters? So this is a mix of geometry and EE. But the math we're really going to use here is our EE skills. So that's the primary thing that's really happening. So what important information do we have? Well, one, we know we're talking about a square. And we know that when we have a square, the sides are exactly the same, which is why to figure out the area, we do side times side or side to the second power. Mean the same thing. Side times side is the same thing as side to the second power. And in this one, they're telling us, what if the side is equal to 1 7/10 centimeters? So that's going to be our goal. So if I were to actually strategically solve this, I know that I would just be doing, I would substitute instead of S times S, 1 7/10 times 1 7/10. That will give us the area. All right, so let's see if we can do some elimination before we actually do that math. If I were to round these two numbers up, if I were just to round this up to 2, so 2 times 2, my answer would be 4. So these numbers are less than 2, so I'm going to eliminate this first one over here. Actually, I'm going to eliminate it like this one red, and my reasoning is it is too large. Okay, because even if I rounded this up, to 2 times 2, my area will be 4. 6, 7, 8 tenths is way larger. So I know that that cannot be the area. All right, looking at the rest of my answers, they're closer. They're definitely less than 4, which is good. So they're closer together. But just not looking at my numbers, if I was going to multiply 1 and 7 tenths times 1 and 7 tenths, I know the first thing I will multiply 7 times 7 to get 49. I know that 9 is going to be important. So I know my guess is that this is going to be my answer. So let's actually test this out. The other two are very, very close together. So let's try it out. 7 times 7 is 49. 7 times 1 is 7 plus 4 is 11. I put my 0 in there, my placeholder. Remember, we don't want to make silly mistakes. And 1 times 7 is 7. 1 times 1 is 1. And I get 289. And I have to move my decimal 2 spots over. 1, 2. To get 2 and 89. So we are actually correct. So I'm just very curious how I'm guessing other people would have made mistakes by either just adding the 2 together. So I'm guessing 3 and 4 tenths would have been if I would have added these two numbers. Yep. So that's what makes this one wrong. It would have been a sum. And 3 and 7 tenths is probably just there as just a random regular number. All right. So we're going to hit pause so you can jot this one down into your notes as well, but we've had tons of practice with using expressions in real life and substituting and following through. So let's get some more practice in Math Marbles. I'll see you in the next lesson. Take care.